Hey everyone, I'm Michael D, and today we are going to be working on examples of using the equation A equals V over T. Or as I tend to write for my students, A equals delta V over delta T, which means just a change in our velocity divided by our change in time. And when we say our change in our velocity, that is our velocity final minus our velocity initial, is how we're going to calculate that. To make sure that everyone's understanding acceleration, if I gave you an example acceleration of 5 meters per second squared, what that means is that we are speeding up at 5 meters per second. So in 1 second, we'll be going 5 meters per second. After the second, we're now going 10 meters per second. After 3 seconds, we're now going 15 meters per second. Acceleration is just a measure of how quickly we are speeding up or slowing down. So let's go ahead and go through 3 examples, and hopefully at the end of these 3 examples, you're starting to feel a lot more comfortable. As I read these questions, I'm going to underline the key terms. Question number 1. We are riding on a train that over a period of 4 seconds, speedy little train, 4 seconds, speeds up from 10 meters a second to a speed of 30 meters per second. Solve the acceleration of the train. We know that this is an acceleration problem because it has the word acceleration in it. And I often get asked the question, when do we use the A equals delta V over delta T instead of the traditional velocity equation V equals D over T? You know that you're going to be using this equation, A equals delta V over delta T, anytime the question has to do with speeding up or slowing down. This is not a constant velocity. This is not an average velocity. Our speed is changing. That means we use the equation A equals delta V over delta T. The first thing we need to solve here now is to figure out what our actual delta V is. How much did our velocity change? Well, delta V is equal to, we have our equation right here, our velocity final minus velocity initial, and I've given you some nice numbers, so you might do this in your head. We ended at 30. We started at 10. So our change in velocity is going to be 20 meters per second. That's how much we sped up. We were going 10, now we're going 30. We sped up by 20 meters per second. Let's fill this into our equation. Acceleration is equal to our change in velocity, 20 meters per second, divided by our change in time. That's the time interval that this took, which was 4. We do this in our heads, unless you really need your handy-dandy calculator. You do 20 divided by 4, and you're going to get an answer of acceleration is equal to 5 meters per second squared. That little squared means we're speeding up by 5 meters per second, and that's how we show this with acceleration. Generally, acceleration is written in meters per second squared. Very seldom do I see acceleration written in, kilometers per hour squared. You could do it, but don't. Let's go ahead and look at a second question. I'm going to scroll down here, and I'm going to underline our key terms. While sitting on the back of a super cool rocket, like all the cool kids are doing, you are accelerated at a rate of 6 meters per second squared. Well, let's underline that. It says the word acceleration. As soon as you see that word acceleration, you know that you're not using your V equals D over T formula. You know that you're going to be using your acceleration equals delta V over delta T. The A is the acceleration, that's the giveaway. For 4.5 seconds. That's our time interval. what will be your change in velocity over this time interval? Let's write down what we know. We know our acceleration, that's 6. 6 equals our delta v, that's our change in velocity, which is what we've been asked to solve. We've been asked to solve the change in velocity. This is divided by our change in time, in this case, 4.5 seconds. Time for a little bit of algebra. To get rid of this 4.5 on the bottom so that we have delta v all by itself, we are going to need to multiply both sides by 4.5. When we multiply both sides by 4.5, on the right it cancels out to become 1, and on the left it multiplies to give us a value of delta v equals 27 meters per second. Pause. This does not mean we are going 27 meters per second. This means our velocity has changed by 27 meters per second. We're going 27 meters per second faster than we were at the beginning of this problem. That's what delta v means. This is our change in velocity. We're going to go ahead and do one more example. Moving up, and we're now doing example number 3. We apply the gas to a motorcycle and begin to accelerate at a rate of 2 meters per second squared. Again, we see that key word, accelerate. You see those units, meters per second squared. Those should all be huge flags that you will be using the equation A equals delta V over delta T. How long will it take to go from 10 meters per second to 40 meters per second? We see two different velocities. We are speeding up in this equation. That's again a flag that you can tell that this is an acceleration question because acceleration questions involve a change in velocity. We're going to get our delta V. We need to know how much our velocity changed by. Again, I've given you some nice numbers here, but really it doesn't matter if it's decimals or not. You could put this into a calculator if you had to. We went from 10 to 40. Take your final velocity, subtract your initial, it's going to equal 30 meters per second. Now that we have our delta V and we have our acceleration A, we can fill in what we know. 2 equals 30 over delta T. Once again, I have put an unknown into the denominator. But I know you clever little cupcakes who have been following along so diligently know how to get rid of something if it is in the denominator. You can say it right now. How do you get rid of this delta T? Yay! I don't know if that works. It works in like little kids' cartoons, but everyone should have just shouted at that moment, multiply both sides by delta T, and then I would like cheer, and I'm giggling a little bit here right now. If you multiply both sides by delta T, they cancel out over here, becomes 1. It leaves us with 2 delta T equals 30. We now want to get rid of the 2. To get rid of this 2, we divide both sides by 2. And to finish this off, delta T is going to equal our 30 divided by 2, which is 15 seconds. And those are the 3 different ways that you could be asked to do acceleration equals delta V over delta T questions. I hope this was very helpful. If you have any questions at all, please leave them in the comments below. Thank you very much for watching, and I hope to see everyone next time.